So my dear students, as we came back to our lecture, now there is a signal classification that I have told you before. I have told you the number of independent variables, how that works, continuous or discrete independent variables, how that works, and how that shows us that how can we understand the signals. There is another signal classification, that's continuous or discrete dependent variables. So it is basically a division of these two signals, continuous time signal and discrete time signal. There is an example of discrete time signal, the stock market index. If it is a chart, you say in that period of time that is a rising phase. In that period of time it trends down, but in some period of time it remains idle. What did it in stock market? If you say that is a Friday, that is a holiday, that will in holiday, if no shares has been sold or buy or any kind of things happened, that will remain void. So there are some differences on it. I will discuss the discrete thing later on when we discuss about the graphical representation of signal. That will be a better view and understanding of it. The third point is the continuous or discrete dependent variable. A signal with a common dependent variable is said to be continuous valued. That means voltage waveform. And a signal with a discrete dependent variable is said to be discrete valued. That is similar to that. The voltage waveform, in each of the time being you have a voltage on it. So there is a continuous part. Discrete is just like digital image. So it is a digital. If it is a digital image, there are so much pixels on it, and they are being activated on each time. In digital image, they can be activated at each time. So there is no rather on and every time you cannot get the value. Okay, a continuous valued CT signal, that is continuous time signal, is said to be analog. That is the analog signal. Now another part of classification came. The continuous valued signal is said to be analog signal. That means that an analog signal has each and every attribute on each and every time. Voltage waveform is an example of voltage. It is an example of analog signal. The discrete valued DT, discrete time signal, is said to be a digital signal. That means digital audio. I will discuss now how that can be audio, digital audio, and how that can be voltage form. There are a lot of things to be discussed now. Now here is the basic thing of graphical representation of signals. Now you can see the difference between these two signals. In a continuous time signal, in each and every point of time there is a value, there is no breakage on that point. No breakage. From 0 to -10, the value is still there. There is no null and void values. From 0 to 10, yes, it travels. There is no, it has some value. It will be some value. Anything else, there is not a vacant value, there is not a null value here, or there is not interval here. In each of the time being, you get the value. That is the time axis and that is the signal axis. You can get the thing on your own idea. If you want to find out in 20, that is closer to 3, that means 2.98 maybe. And if you take 30, in time 30, you can get in that position, that can be 1.3 in that value. So each and every time you get the value. So there is no breakage here, or you can say no intervals are there. But in discrete time signal, you get the interval between these two. There is no such a time. These things are known as samples. They are not known as the time function, that is samples, and that is the discrete representation of signal xn. In some of the books they use first bracket, but if you use the third bracket with an n, with an n, so you can get the discrete signal. This representation is largely known as discrete signal, xn, yn. You can write it down. Look here, in 0 you get 2.5, in 0.1, 0.5 there is no value. That means in this here we get every fractional value counted, but there is no fractional value counted here. There is a limited value. There may be interval of 0.52, but there are intervals. There are no such a continuous point there. From 1 to 2 interval is 1, 2 to 3 interval is 1. There is an interval. In this interval you get 1, means the value on the sample of 2 is 1. The value of sample of 3 is 1.5. Minus 1 is 1.5. Minus 2 is 1.5. Thus you can calculate it. That is known as discrete time signal. So my dear students, now I think I am able to give you some knowledge about continuous time signal and discrete time signal. For your kind information and better understanding, I am repeating this thing again. In continuous time signal, it is a mere representation of time and function of time. In discrete time signal, it depends on samples. What does it? Samples. Okay, and each and every sample has a value, has a certain value. In 0, it's a 0 point, that is a sample. You get this. How do you write this? Okay, if x0, the value of x0 is such like in this point, this means 2.5. But if you write xt, so you have certain value too. If x10, so that is a certain value of 3 here. It is x10, it means the 10 second or 10 minute, whatever else it may be. It's not, it's 10. That means that's not the thing. 10, that's 3. If it is 10.1, that gradually goes down, that means 2.99. There is another value, 10.1 x. But here there are different samples, x1. So you have to write x1. That means there is discrete signal. Discrete signal has a certain value. That means there 2.8. There is 2. 2 is 1. There is 1. That means the value of this in value there. I will make it clear now. In 0 point, that means x0, in that index, that is known as index, the point here is 2.5. Okay. Now if we take x2, what is the value? x2 is equal to that is similar to in this line, so the value will be 1. I think you have understood that how we calculate or how we take the value of discrete signals. Okay. So my dear students, last one, if we take x minus 1, the value will be 1.5. That's it. Thank you very much for being with me.